Hello, my name is Harris McIntosh, and this is my podcast for Professor Lewis's calculus class. And we were supposed to go over mainly about derivatives and rules and such. So I've got 5 exercises here that I chose from exercise 3.3, the problems that we were supposed to do. And along the way, I'm going to explain how the various rules works and what you're supposed to do while you're trying to solve these sorts of problems. So anyways, let's go. So first I started out with number 7, and number 7 is w equals 3z to the negative second minus 1 over z. And in this problem we're going to be using the power rule. The power rule is basically when you take the exponent, multiply it by the number in front, and then you subtract that exponent by 1. So I wrote down w prime equals the derivative of 3z to the negative second minus 1 over z. Now, I got the derivative of 3z to the negative second, which is negative 6z to the negative third. However, I can't get the derivative of 1 over z because the variable is in the denominator. So what you're going to want to do for that is get the variable on top. And the way you do that is putting the variable into the numerator and changing the sign. So if it was positive, you make it negative, and negative vice versa. Alright, so you would end up getting, for the derivative of 1 over z, you would end up getting positive z to the negative second, because a negative times a negative is a positive. So the final answer would be w prime equals negative 6z to the negative third plus z to the negative second. Alright, so just remember, no variables in the denominator when you're trying to find derivatives. Alright, so next we got number 17, and that we're going to be using the quotient rule. And the quotient rule is basically when you have two functions that are dividing with each other. And the easy way to remember the quotient rule formula is low d high minus high d low over low squared. So basically, the function on the bottom times the derivative of the function on the top minus the function on the top times the derivative of the function on the bottom all over the function on the bottom squared. Kind of hard to remember a little bit, but it is what it is. Um, so basically what I started off, you set it up. It would be 3x minus 2 times the derivative of 2x plus 5 minus 2x plus 5 times the derivative of 3x minus 2 all over 3x minus 2 squared. So you find the derivative of 2x plus 5 and 3x minus 2, and they're both equal to 1. And if you have numbers like singular numbers once you get the derivative, you're going to want to put them in front. So it would be 1 times 3x minus 2 minus 1 times 2x plus 5. Now, with 3x minus 2, they're asking you to get the square. But when you're getting the square of it, they're not asking you to just put the 2 on the variable, because that's not it. You have to square the whole thing. So it would be 3x minus 2 times 3x minus 2. And factor it out, you would get 9x squared minus 6x minus 6x plus 4. Now, then you would combine like terms and get 9x squared minus 12x plus 4. You take that, and then you use that as your low squared. So the answer would end up looking as y prime equals 3x minus 2 minus 2x plus 5 over 9x squared minus 12x plus 4. And that was the problem using the quotient rule. Now next, we have number 37, which is dealing with radicals and e. And so basically, with the radicals, you're going to want to change that into a fraction. Now, the problem's asking, find the derivative of y equals 7 times the root of x squared minus xe. So what you're going to want to do first is make that radical into a fraction. So you take that 7 and put it under the 2. That would make it x to the 2 over 7th. You're going to want to multiply that 2 over 7 times the number in front of the variable, which is 1, so it'll be 2 over 7x, and then subtract 2 over 7 by 1, which would be 7 over 7. 2 over 7 minus 7 over 7 equals negative 5 over 7. Now with x's and e's, really you just move it around, kind of like if it was 1. If you subtract e by e, it's still going to be e. If you multiply a number by e, it's going to be e. So the negative x to the e would equal ex to the e. So your final answer would be y of y prime equals 2 over 7x minus 5 over 7 minus e of x of e. E times x of e, my bad. And this was a problem using radicals and e. Weird. Alright, so for 47, this is kind of a little bit of a mixture, because what we're going to be doing is using both the quotient rule and the product rule. Now, we already know about the quotient rule from, I think it was number 17. Yeah. The product rule is basically multiplication. You're going to want to use that when you're multiplying two functions together. And you'll see when we have to do that in this. So first, you got to set up your problem. It'll be r prime equals x to the third times the derivative of x minus 1 times x squared plus x plus 1 minus x minus 1 times x squared plus x plus 1 to the derivative multiplied by the derivative of x cubed all over x cubed squared. Remember, low d high minus high d low over low squared. Alright? So to find that derivative of the high part, you'd actually have to use the product rule. This is where it comes in. So you would take the first function and multiply that by the derivative of the bottom function, the second function, and the second function multiplied by the derivative of the first function, and add those together. So x minus 1 times the derivative of x squared plus x plus 1 plus x squared plus x plus 1 times the derivative of x minus 1. And what you would end up getting is x minus 1 times 2x plus 1. And since the derivative of x minus 1 is 1, you would add, it would end up being x minus 1 times 2x plus 1 plus 1 times x squared plus x plus 1. So your final answer would end up looking like x cubed times x minus 1 times 2x plus 1 plus 1 times x squared plus x plus 1 minus 3x squared times x minus 1 times x squared plus x plus 1. And you got the 3x squared by finding the derivative of x cubed. So 3 times x equals 3x. Subtract 1 from the exponent, you get 2. Then you would square the denominator, your bottom function, and that's x cubed. So x cubed squared is x to the 9th. And there's your answer. So that's 47. Remember, always do it in order. Sometimes when you have your quotient rule, you're gonna have to, use the product rule if you have that one that's multiplying with each other as a derivative. Now, for 65, they're asking you to find the tangent of a line parallel to a point. Now, first things first, you are going to find derivatives because derivatives are equal to the slope. The derivative is necessary to finding the slope. So whenever somebody says finding the slope, really and truly you're trying to find a derivative. So they gave us y equals x cubed minus x, and the coordinate is -1, 0. Now first, so what I did is y prime equals the derivative of x cubed minus x. Alright, derivative of x cubed minus x is 3x squared. 3 times 1 equals 3. 3 minus 1 equals 2. And then the derivative of, x is 1, because any number that has an exponent of 0 equals to 1. So it's 3x minus 1. Then what you want to take is your x value and plug it in. So you would do 3 times negative 1 squared minus 1. So 3 times negative 1 is negative 3. Negative 3 squared is 9. 9 minus 1 is 8. That will be your slope. So your slope is 8. Remember that. Now another function that's going to be vital to this is the point slope equation. So that would be y minus y1 equals slope times x minus x1. And we got all the values that we need right now. So we're going to plug those in. Uh, y minus y1, or should I say y minus 0, and m is equal to 8. So 8 times x minus negative 1. You're going to multiply your slope into the equation, so it ends up looking like y minus 0 equals 8x plus 8, because a negative minus a negative is a positive. Well, a negative times a negative is a positive, and 8 times positive 1 is 8. You want to add 0 to both sides so you could move it to the other side. You would end up getting y equals 8x plus 8. And that is the function of the line parallel to tangent. So, blah. Anyways, this is the end of my podcast. I hope you've learned something for it. I might have gone a little bit fast, but I'm kind of recording on this crappy little cell phone because computer bugging. Anyways, hope I helped you out. Hope. Thank you for listening. Have a great day. Hope we have a great semester and year together. Bye.